Hi, I heard you went to New York this year. Did you see Van Gogh's masterpiece, Starry Night?
Yeah, I saw it. It's really beautiful.
Guess what? Don't be shocked. I'll tell you a crazy thing. Computers can learn to paint like Van Gogh.
What? Using machine learning?
So smart, yes. Let me show you the work.
It's unbelievable. How can you do it?
For that, akin to human imitation artist, an algorithm should first be fed the original artist's creation, and then it will be to generate a machine taken on them. Before the algorithm, let's talk about the tools. It's Wolfram language. It is a knowledge-based programming that builds in as much knowledge as possible, such as texture synthesis, and as automatically as possible, it can define anything you want. It can mix input natural language understanding, and also it can provide universal deployment totally on cloud. First, you should know what is inpainting. The term digital inpainting was first introduced in the image inpainting article at the SIGGRAPH 2000 conference. The main goal of inpainting is to restore damaged parts in the image. However, it is also widely used to remove or replace selected objects. In the Wolfram language, inpainting is a built-in function. The region to be inpainted or retouched can be given as an image, a graphics object, or a matrix. There are 5 different algorithms available in inpainting that one can select from using method option: diffusion, total variation, fast marching, Navier-Stokes, texture synthesis, which is default setting. Texture synthesis, in contrast to other algorithms, does not operate separately on each color channel, and it does not introduce any new pixel values. In other words, each input pixel value is taken from the parts of the input image that correspond to 0 element in the region argument. The texture synthesis method is based on the algorithm described in image texture tools. Parameters for the texture synthesis algorithm can be specified via 2 sub-options: neighbor count and max samples. The first parameter defines the number of nearby pixels used for a texture comparison, and the second parameter specifies the maximum number of samples used to find the best fit texture. In the example below, it is clearly visible that these properties of the texture synthesis algorithm make it the method of choice for removing large objects from the image.
Well, how to use the method to extrapolate Van Gogh's painting?
Here are 3 steps. First, you need to import the painting and remove the border. Next, you need to extend the image by paddling it with white pixel to generate the inpainting region. Third, you can extend the painting using a texture synthesis method. Or different effects can be obtained by changing the value of the neighbor count and the max sample sub-options.
I get the idea. Let me try it by myself. First, I import the painting and remove the border. Next, I extend the image by padding it with white pixels to generate the inpainting region. Now I extrapolate the painting, use texture synthesis method, and I tried several different values to these parameters.
Have you ever tried on other paintings?
Yes, of course. I tried Van Gogh's Starry Night over the Rhone, and the results turned out to be pretty well. However, when I tried these algorithms on other paintings, such as Pierre Mondrian's composition, since this painting got lots of straight lines inside it, the results turns out to be not so well. And when I try other parameters, some parameters make the situation worse, and some parameters turns out to be a little bit better. And when I try the painter's other paintings, and since they also have some straight lines, the results is also not so well. However, when I try Claude Monet's water lilies, it is extraordinary. It looks exactly the same as its original paintings, and you cannot even see the difference.
Here is the end. Thanks for watching.